In this nugget, you and I get to look at the concepts behind Dynamic Host Configuration Protocol. Let's begin. I'd like you to imagine that you and I are the network administrators and designers of this network. And what you and I have decided is that this network over here to the left, we're going to name it the 10.1.0.0 network. And we'll make this a 16-bit network. Now we're going to have a dedicated set of nuggets just for IP addressing. For now, I'd like you to know that the first two numbers here, the 10 and the 1, in this example, represent the street name, also known as the network number for our network. So this network is going to have the name of 10.1. Now, one of our challenges in this network is that every device is going to be on the 10.1 network. That's not so tough, but each of these devices also needs to have its own unique host identifier or host address. And the host address I'll have right here in green in our network is going to be these last two numbers, 0.0. So maybe this computer is going to use 0.100. And maybe computer 2 is going to use 0.101. And the printer is going to use 0.102. Now, if you and I went in and we manually had to implement each of these IP addresses on each of these devices, that's referred to as static configuration of IP addresses, where we manually do it in a static fashion on each and every device. And we may use static in a production environment on critical devices. For example, on a server, where we always want it to have the same exact IP address. Or a router interface, where we want it to have the exact same IP address every single time. However, for other devices like computer 1 and computer 2, if we want to optimize your and my time as we give IP addresses to these devices, instead of configuring the computer statically, we can use DHCP, which stands for the Dynamic Host Configuration Protocol. It's a way we can automate the assignment of IP addresses to devices on our network. And the basic concept of DHCP is done between a client. A client is a device that would like to get an IP address, and a DHCP server. That's a device that knows about a pool of IP addresses it can hand out and is willing to do so. And here's the play-by-play. The client, when it wants an IP address, issues a discover message. And effectively, the discover is saying, hey, I'm looking for some help. I need a DHCP server who could possibly assign me an IP address. And the DHCP server, if it hears that message, is going to respond, and it's going to respond with an offer. And in that offer, it's going to say, hey, I've got a beautiful IP address. I think you'll like it. It's yours for the taking. To which the client can say, great, I'll take it. And that's called a request. And then there's a final message that's sent from the server back to the client, and it's called an acknowledgement. I'll put ACK for short for acknowledgement. And then that acknowledgement is just going to confirm the details. For example, this is the IP address that you're going to use, as well as additional options that the DHCP server can provide to that client. And a great way to remember this back and forth for DHCP between the client and the server is through a children's cartoon called Dora the Explorer. It doesn't even rhyme, but it doesn't matter too much. DORA, which stands for discover, offer, request, and acknowledge in that order. Now, to set this up, we need to identify a device on our network that will act as a DHCP server. Now, we could have the router. If the router supports that function, we could add this DHCP service on the router itself, or we could have it done on a server. For example, a Windows server is very able to be a DHCP server as well. So it just depends in our network what we have available to be acting as a DHCP server and where we want to enable it. So whatever device we choose to use as a DHCP server, whether it's a router or an internal server, we're going to identify on that DHCP server a pool of addresses. So in this case, it would be on the 10.1.0.0 network. And maybe our pool addresses will be from 0.200 through 0.225. So again here the 10.1 represents the network portion, and the 0.200 through 0.225 will be our individual host addresses that we're handing out to DHCP clients. And there's a fancy name for that pool, and they call it a scope. So if we see the concept of scope, simply think of that as a range of DHCP addresses that a DHCP server is willing to hand out to people that ask for it. Now, if we do have a client, let's say computer 1 becomes a DHCP client, and it sends out a discover, and there's an offer, and the request, and the acknowledgement. How long exactly does computer 1 get to keep and use that IP address? And the answer is, it depends on the lease. For example, a DHCP server could say, okay, this lease is good for 8 days, which would imply to the DHCP client that before that 8 days runs out, it needs to make other arrangements. Either it needs to renew that lease for another 8 days, or it needs to find another DHCP server. But the lease information is the amount of time that a DHCP client is allowed to use the IP address that's been dynamically assigned to it via DHCP. Now, sometimes when I go out to eat for fast food, I'll pull out the food, and in the very bottom there will be some fries in the very bottom. I'm thinking, wow, cool, bonus, some extra fries. Well, inside of a DHCP offer, as well as the acknowledgement, there's also included some DHCP options. And options can be very handy for a client. For example, in this network, computer 1 needs to know about the IP address of its default gateway that it can use if it ever hopes to get off of the local network. So one of the prevalent options that we'll often see inside of a DHCP offer, as well as the acknowledgement, is the option of a default gateway for that client to use. Another very important aspect would be a DNS server. DNS stands for Domain Name System. We'll have a separate nugget just on that. And a DNS server gives a client the ability to translate the name, like www.cbtnuggets.com, to an IP address, which is critical for IP communications to work. So 2 examples of options inside of a DHCP message would include a DNS server and a default gateway for the client to use. And there may be situations where we want a client to be a DHCP client, but we don't want that client to get a random IP address. Instead, we can set up a reservation. And we're all familiar with reservations. If we have a reservation at a restaurant, we show up and boom, they take us to the table. Well, in DHCP, the reservation isn't just guaranteeing a table, it's also guaranteeing an exact table every time for a client. So if computer 1 had a reservation for the IP address of 0.206, the DHCP server, when assigning an IP address to that computer, would assign that specific IP address due to its reservation. Now, one of the challenges that we're going to have in our networks is that maybe we don't have a DHCP server directly connected to every network. And maybe we don't want our routers who are connected to every network to act as DHCP servers. Is there a way that we can have one centralized DHCP server, for example, over here, be the DHCP server for multiple different networks? And the answer is yes. And we do it with a little feature called IP Helper or IP Relay. And it works like this. On our DHCP server, we'd create multiple scopes. So we have a scope for subnet A and subnet B and subnet C. And for each of these scopes, we've also identified options such as DNS servers and default gateways. And then we ask this router, through configuration, to be a good buddy, and anytime it sees a DHCP discover packet, to go ahead and wrap it up and ship it up to the DHCP server. At which point the DHCP server will look at that packet and determine, oh, this came from this specific subnet. Let's say it's subnet A, for example. The DHCP server will see that it has a scope for subnet A, and it will offer an IP address from that pool back to the IP helper function. In this case, the router using the IP helper. At which point the router would make the offer back to the client. So it's like Dora happening twice. So here we have the client, here we have the relay, and here we have the server. And I'll box the client as well over here. So the client does the discover, that's forwarded to the server. Then there's the offer that comes back this way. Then the request, and then the acknowledgement. And you might think, well, Keith, why does the router have to act as a helper for DHCP? And the fact of the matter is, this client computer does not yet have an IP address. It does not yet have a default gateway. It can't, on its own power, get off of the local network segment because it doesn't have an IP address and it doesn't know anything about the default gateway to use yet before it has an IP address assigned to it. In this nugget, we've taken a look at the concepts behind Dynamic Host Configuration Protocol, along with several of the terms and concepts associated with DHCP. I've had a lot of fun in discussing DHCP. I'm glad that you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.